Identify the middle coefficient, which luckily is divisible by 2, so it's 8. 8 divided by 2 is 4, and we square 4, and we get 16. So then the new equation is this. Now the left-hand side is very clear, because by now it should be very clear because we have an agreement on these three special products. So the left-hand side is, and the right-hand side is 49. So can anyone give us the left-hand side? What do I have in here so that, exactly. The first term squared plus 2 times the first times the second plus the second term squared. So at this point in time, I have to take the square root, remembering that this is a quadratic equation, and I have to write plus or minus 7. Then I have to move negative 4 to the other side, and then we get two options for x. And the first option is negative 4 plus 7, which is positive 3, and negative 4 minus 7, which is negative 11. Okay? Everything okay? I looked at your progress in my math lab, and several of you have absolutely 0 so far. Nothing done. So I hope that that's not going to be the case between now and Monday. Okay? Please. Please. You're part of a team, and we are all part of a team, and we want to move forward together. Okay, 1.2.103. So let's take a look at that problem. Can you, before I find it, can you tell us what it is all about? For some reason, I logged myself out.
Just proportion of correct responses with the another variable x, which is.
So you said 1.2.103. Okay, I'm getting this message now. I'm not sure what is going on here. Okay, I think it opens now. Okay. And you said this was in 1.2. Is it towards the last one?
Let's see what number it was.
That's okay.
I think it was. I think I have like one more problem after.
Oh, it probably will allow me to go directly. Okay, so you said 13 or 14?
Yeah.
This one? No, this one we did last time. Yeah. This one? We did that too.
No, I think it's the one right after that.
This one?
Yes.
Okay, so we have a model. It has so the model P is a learning curve where P is the proportion of correct responses after X trials. So every time I solve a word problem, like for example this one, I take notes. Absolutely mandatory. So I write P is the model, which is 0.7 x minus 0.8, everything divided by 0.7 x plus 0.1. I will write P proportion of correct responses. I write X, number of trials. So this is absolutely important, because then I will not know what is asking me, what I'm doing, and so on and so forth. These are my first notes. If P equals 0, there are no correct responses. So P equals 0, no correct responses. If p equals 1, all responses are correct because we're talking about proportions, right? So 1, all correct. Or if you want probability, 0, nothing is correct, 1 is, they're all correct. Okay. The graph of the rational formula is shown below. How many learning trials are necessary for 0.82 of the responses to be correct? So now I look at this, and by notes, I am told, one more time, let's read it. How many learning trials are necessary for 0.82 of the responses to be correct? What is given, and what am I asked to find? I'm given P, very good, and I'm asked to find X. So when I'm given P, it means I'm given which of the two variables, the one that is on the vertical axis or the one on the x-axis. I know it's a silly question. Yes?
One's on the y.
Of course, P is a variable, the y variable, of course, very good. So I look here, I see that this is 0.8, this is obviously 0.9, and this is 1. So 0.82 will be very difficult to figure out. I cannot even enlarge it. It doesn't allow me to, because I'm not in the solving mode, I think. I don't know. Oh, it's right here under my nose. Sorry. Right under my nose. Okay. So this is 0.9. 0.5 should be about here. 0.2, I'm going to estimate it right here at 7. So I'm going to plug in 7. That's my estimate. Is there a second part of the question, or that's just it? Is there a second part? Okay, this corresponds to the point, yes. So the point is obviously 7, 0.82. So I will put in parentheses this 7 and 0.82. And is there a third part, or is it done? I think it's done. Okay. Any questions? Is this okay?
Yeah, that's how I did it. I'm not sure why I didn't make it unless maybe I put a space in between the
Yeah, sometimes it does that. Yeah. Very good question. Thank you for bringing that to our attention. Anything else? Other questions? Anything else that you worked on? Anything? Is there anything else? Anything else? Okay, so any questions from 1.5? Anything that you'd like to go back to? If not, we'll continue with 1.6.
We're going to save after class.
Sure, absolutely. So 1.6, other types of equations. If you want to work on any problems after class, if you want to just sit down and go over a study plan or anything, please stay, right? So I don't want to forget to tell you that. Okay. How many types of equations we know so far? 3. Very good. Awesome. We know linear. We know rational. And we know quadratic. Even with 4 methods. Gee. Okay. The list will be 8. So we have 5 more to look at. And also later on in chapter 4, we are going to add 2 more types. So for the entire semester, we're going to have 10 different types of equations to look at. Okay, these are 3. We're going to look at 5 more. And then till chapter 5, we're going to be 4. We're going to be okay. We're going to add 2 more then. Okay. So the first one is polynomial. In this section, 1.6. Polynomial equations. And you could say, and I will have to say you're correct. But what was linear and what was quadratic? Aren't they polynomial? Yes, they are. But when we really talk about polynomial equations, we mean higher degree. Higher degree than 2, like 3, 4, and so on and so forth. Higher degree. So let's look at the first example. We are on page 185. If you feel like choosing, please do so. Problem 4 on 185. 4x cubed minus 12x squared equals 9x minus 27. First thing I have to identify is the degree of the polynomial. I'm going to ask you, is it a polynomial equation? And you have to say yes, it's a polynomial equation. Because the polynomial has degree. Which degree? Is it 1?
Third.
Very good. Third degree. Perfect. We are going to write that somewhere at the beginning as a reminder. Third degree. How many solutions will I have to find? And this is my reminder.
3.
Exactly 3. Degree 15, 15 solutions. Degree 100, 100 solutions. If it's a polynomial, of course. That's what we are talking about. Good. So we identify the equation. It's polynomial. Now let's look at this polynomial and say, what type of polynomial is it? Is it a binomial, a trinomial, or a polynomial? Correct. What I have to do is set it equal to 0. So these two terms will move to the other side, and I will change their sign. 4x cubed minus 12x squared minus 9x and plus 27. Now back to the factoring supplement that we finished last time. Okay, so what do we do now? It's a exactly. That's the only way. But I have to say, is it in descending order, greatest common factor, negative leading coefficient, special product? There are none, and obviously grouping. Remember, if the first two and the last two are not going to lead us somewhere, in other words, we're not going to be able to factor, then we have to try the first with the third and the second with the fourth. If that doesn't work, then we have to try the first and with the last and the middle two. And only then we can say nothing works. I tried all 3 possibilities, not factorable. But not until then. So we always should try the first 2 and the last 2. What will you factor out from the first 2? Excellent. 4x squared. And what is left? Very good. What should I have from the other 2? Otherwise, I can continue. I write it, excellent. I write it first because I may come up with something else. Who knows? Good. Now remember, 2 things are required. If you write these 2 like this, that will be incorrect. Notice that I left space for sign and factor. You can continue without coming up with a sign and a factor. So what is the sign and what is the factor there? Do you all agree with negative 9? Bless you. You can check very easily. Negative 9 times x is negative 9x. Negative 9 times negative 3 is positive 27. Now, these are 2 terms, like we had from the supplement. Remember? These are 2 terms. What comes out? The common factor, which is? Very good. And what is left in parentheses? Notice that I immediately wrote the equal symbol and 0, because if I forget this, I'm not going to solve. I'm changing it into an expression, and that would be incorrect. 4x squared minus 9. I know that this is a linear factor. It cannot be further factored. But this, I have a special product for it that we talked about from the very first day of classes. Difference of squares. Excellent. So then I continue factoring. I have to completely factor till there is nothing else that I can factor. So since it's a difference of squares, what do I have in here? From each factor, I will get a solution. Please set equal each factor to 0 and give me 3 solutions. So set x minus 3 equal to 0, set 2x minus 3 equal to 0, and 2x plus 3 equal to 0 by the zero product principle. Zero product principle. Zero product principle. A product is 0 only if each and every factor could be 0. I mean, if a factor is set equal to, if a product of factors is set equal to 0, then any factor can be 0. So then we get 3 solutions, and they are from here x equals, from here x equals 3 halves, and from here x equals negative 3 halves. Remember, you have to move the terms to the other side. This was negative, goes to the other side positive. This was negative, it goes to the other side positive. This was positive, it goes to the other side negative. So that's how we solve polynomial equations. And I think we should look at another. Is that okay? Yes? Yes, please. Yes,
So,
please.
all three of those would be the answer, x equals 3, x equals 3 halves.
Absolutely.
Okay. Oh, yeah, 3.
We started with degree 3. That's why we wrote it, so we don't forget.
Okay.
And we established that from the very beginning that we have to come up with 3 solutions because the degree is 3.
Okay.
Very good. Is this okay? Perfect. So let's take a look at another, like, for example, number 2 on page 185. So 5x to the 4th minus 20x squared equals 0. Okay, so now let's identify the equation, and then we talk about the polynomial. So let's identify the equation. The equation is, it's polynomial, correct? Very good. Now the next question is, what is the degree of this?
4.
Yes. So degree 4, how many solutions?
4.
4 solutions. I wrote myself a note so I don't forget. A note that is very important here. Never divide by a variable. Because remember, there are 2 key words, factor and simplify. So because I have to have 4 solutions, I am not allowed to simplify or divide both sides by x or x squared, because I will not have 4 solutions at the end. So dividing by a variable is never an option. But I can simplify dividing both sides by 5. So I have x to the 4th minus 4x squared equals 0. So we divide by 5. 4x to the 4th divided by 5 is x to the 4th. Negative 20x to the squared divided by 5 is 4x squared. And 0 divided by 5 is 0. I will always simplify if I can. The numbers will be easier to handle. And division by 5 does not change solutions in any equation. So now I will ask you, what type of polynomial is this? And now I'm asking if it's binomial, trinomial, or polynomial. So initially I was asking what type of equation. The equation is polynomial. It's not linear, it's not quadratic. And now this is a, very good, it's a binomial. It's in descending order. Greatest common factor? Yes, which is? Indeed. So what is left in parentheses?
X squared minus 4.
Excellent. I have to continue with x squared minus 4. That's why I tortured you with this from day 1. It will pop up constantly. So what do I have with x squared minus 4 then? Good. Remember the equal symbol and 0. If I don't write the equal symbol and 0, if I forget, then I'm only factoring, not solving. So what do I have in parentheses now? Instead of x squared minus 4, I have? Excellent. So now I have 4 solutions. These are 2 factors, x and x. So even if all solutions are the same, I still have to write them. So from here, I have the first solution as x equals. This is x times x. So if x is 0, x is 0. If x is 0, x is 0. If this is 0, x is? Very good. If this is 0, x is? That's it. So even if solutions repeat, and you'll see in chapter 3 how important this is.
How are you the first two zeros? Like x equals 0, x equals 0?
So when I use the zero product principle, I have to set each factor equal to 0.
Oh, okay.
When I said this factor equal to 0, this factor, I get one number. If I said this, so that's why I said this is x squared, which is x times x. When I said the first equal to 0, I get 0. When I said the second equal to 0, I get 0. When I said the third equal to 0, I get -2, and the fourth one, x equals 2. Better? Good. Any questions, please? Any questions? Yes.
The dividing product of 5x4, you said never divide by variable.
Yes, in other words, do not divide by x or x squared. Because if you do, then you will never find 4 solutions.
So what was the answer?
The answer is 0, 0,
Okay,
-2,
so you
2.
did both. Okay, you put down. Okay.
These are 4 solutions as we expected. 4 solutions. Even if 2 of them repeat themselves, that's fine. It's very possible. Any questions?
I do have a question.
Please.
About number 4.
Yes.
So the answer.
You mean on the previous problem?
Yes.
Okay. Yes.
So yeah, I get the x minus 3 equals 0 because no, I don't. Maybe I don't get it.
Are we talking about the solutions, the final solutions?
Yes, the final solution.
Okay. This is a linear equation that we know from a long time ago,
Okay.
right? So when I solve x minus 3 equals 0, I have to -3. I move it to the other side, and I get 3. Only 3 minus 3 will be 0.
Right. Okay.
2x minus 3 is 0. I move -3 to the other side and divide by 2, and I get 3 halves. It was negative here, it becomes positive.
Okay.
Here it was positive, I move it to the other side, becomes negative, I divide by 2. So that's why I listed these that we already know. It's always good to ask a question because we'll go back and we'll refer to what we covered, and that's how we connect the concepts. Very good. Any questions here? Any questions? Okay, the next type, radical equations. Radical equations. When we talk about radical equations require us to use a procedure that is not 100% legitimate. And you can say, what do you mean by that? I mean that when we apply that procedure, we may or may not get solutions that work in the original problem. And you can say, but then why use it? It's the only one we have. So here's an example. So if I write that x equals 2, what type of equation is this? Perfect. Will I ever have a need to square both sides?
No.
No, absolutely never. Bear with me. Bear with me. So let's square both sides. The left-hand side squared is? The right-hand side squared is? 4. What type of equation is this?
Linear.
It was linear. Now it cannot be linear anymore. It's not rational because it doesn't have x in the denominator. What is the third one we know? Exactly. But how many solutions does the quadratic equation have? Right. Can anyone give us the solutions and which method we should apply for this?
It would be 2 and negative.
Correct, because I'll take the square root. That's the best method here, right? It's already set up for that. So let's take a look again. I started with this equation, which has how many solutions? And I ended up having this equation with 2 solutions. Which of these 2 solutions is correct here and which one is not?
2 would be correct.
Right, x is okay, x equals 2 equals okay, and x equals -2 is not. So I'm only illustrating that the principle of raising both sides to a power can create solutions that do not work in the original problem. That's all I'm illustrating with this. We'll never square x equals 2. Never. There is never a need to do that. But all I'm explaining with this example is that when we square both sides, cube, fourth, whatever we need, then we the final solutions have to be checked in the original problem. Mandatory. It's part of the problem. Why? Look at this simple example. We started with a linear. We ended up with a quadratic with two solutions, but one of them does not work there. Okay? So, when do we apply this principle? And here's the first example. Let's say problem 12 on page 185. So let's say the square root of 20 minus 8x equals x. If you have your books or if you want to choose, I'll be more than happy to work on the problem you want to pick. Okay, what type of equation is this? Radical. Now, what power is the square root? So if I write the square root of 2, I mean 2 raised to a power. Which power? That will not be true, right? That will not be true. So 2 squared is 4. 2 to negative 1 is 1/2. So none of those work. So what is the power then?
0.
Power 0, 2 raised to 0 is 1. It has to be a fraction. It has to be a fraction. If it's the square root, it must be a fraction. Which fraction? Say it again. Fraction. 1/2. So remember, the square root of 2 is the same with 2 to 1/2. It cannot be power 2 because that's 4. It cannot be power negative 1/2 because it's negative 1 because it's 1/2. It cannot be power 0 because it's 1. All radicals represent fractions as exponents. Okay, so can anyone give us now the cube root of 3? Very good. So please remember, any radical represents an exponent that is a power. An exponent that is a fraction. Sorry.
Say it one more time.
Any radical is a fractional exponent. Any radical is a fractional exponent. Any radical is basically a fractional exponent. All radicals represent exponential notations with a power that is a fraction. Good. So then, since this is basically what power again? Very good. What should I do to both sides to eliminate that power? Not multiply, but raise both sides to which power? But if I have, exactly, if I have 1/2 multiplied by 1/2, I will get 1/4. So I want 1/2 multiplied by what power to eliminate this? Exactly, because only 1/2 times 2 will be 1. Because remember, we copied the base and multiplied the exponents.
So if it was like the cube root?
Yes, if I have the cube root, I would have to raise to the third power because the power inside is 1/3. If I have index 4, what will I raise to both sides? Right, perfect. Good. So the left-hand side will become, and the right-hand side will become. Very good. So now what type of equation is this? Very good. I have to set it equal to 0. Move this to the other side, move this to the other side, and I like to keep everything on the left. So negative 8x was negative here, moves negative, moves positive, was positive, moves negative. Okay, so then my question next is, what do I do now? I have 4 methods. Will I complete the square? Absolutely not. Will I take the square root? I can't. Will I use the quadratic formula or factor? If factoring takes more than 30 seconds, forget it. Quadratic formula. Can we factor quickly?
Wait, why is it negative 40?
It was positive on one side, and I moved it to the other side.
Negative, or 10 and negative.
Yes, so x plus 10 and x minus, is that clear?
No, because
It's
I'm saying they
negative.
moved on the other side.
It's negative, and I moved it to the other side where x squared is positive. X squared stays positive. This was negative, and I move it on the same side with x squared. It becomes positive. And this was positive, and I move it on the same side with x squared, and it's negative. I just don't want to write 0 on this side.
Okay.
Just for convenience. Just for convenience.
Okay.
It doesn't matter. You can write 0 equals. Will be the same thing. I just prefer writing the polynomial and 0 on the other side. Okay, so then there are two options for x. Can anyone give us those options? Right, good. But remember, this is not entirely legitimate. What does that mean again? It means that I'm forced to go back and check. And I have to go back and check back to the original problem. Remember, this is not the original problem. The original problem is this. The square root of 20 minus 8x equals x. I plug in negative 10. Negative 8 times negative 10 is positive. Perfect. Plus 20.
100.
The square root of 100. Very good. Awesome. Very good. But this side is negative 10. Will I accept negative 10 as a solution? I can't. Not acceptable. It doesn't work. 10 does not equal negative 10. So now the next step is I check 2. Negative 8 times 2. 20 minus 16. The square root of 4.
2.
The right-hand side.
2.
Do I accept x equals 2 as the only solution? I'll say yes. So now you see the process applied to where it belongs, not to x equals 2. All I was saying here is to show you that it is possible, not necessarily, but it's possible to get solutions that do not work. And we did. In this example, we got x equals negative 10 and x equals 2, but negative 10 doesn't work. We went back to the original problem, and it doesn't work. So again, we call this, you don't need to remember this, but it's called extraneous. A byproduct, right? That is not, doesn't do any good. Extraneous solution. Something that we didn't need, but it's there. Extraneous solution. I'm ready for another one. Any questions on radical equations? Say it again.
It's page 185.
Yes, page 185. I recommend problems between 11 and 22. And 22 on page 185, and we want to look at 21. Very good, 21 it is. So we have the square root of 3x plus 10 equals x plus 4.
Is this outside of the
Yes, it is. Let me check, because sometimes I
It
copy.
is.
Sometimes I do copy something else. Thank you for being vigilant. Okay, so now, in this particular, first of all, I'm going to ask you what type of equation is this? It's a radical equation because it has a radical in it, right? There's no division by a variable, so it's a radical. Good. What would you do first? And always remember, clean it up or factor simplify. Factor simplify. This has to be forever in the back of your mind.
put the 10 on
Exactly. I need to clean it up. I will not be able to square in this stage. Very good. So the square root of 3x equals x minus 6. I moved 10 that was positive from the left. It becomes negative to the right. 4 minus 10 is negative 6. Now, one very important note. Let's look on the side here. It's a simple example. Is 2 plus 3 5?
Yeah.
What if I make the mistake of saying, okay, 2 squared, 3 squared, 5 squared? Is 4 plus 9 25? No. So the point I'm making here is I have to square the left-hand side as one unit, and I have to square the right-hand side as one unit, not term by term. I will get a total error. So then the left-hand side is? Very good, awesome. And before I ask you what is the right-hand side, I'm just going to bring up the agreement that we have from the first day of classes. And you will tell me how many terms I have to write. Very good, 3 terms. We have an agreement. Go back and review this every day. Please go back and review these every day. 3 terms. 3 terms. Okay? Good. So can anyone give us those 3 terms? Awesome. Now I'm going to ask you again, what type of equation is this? And you will say quadratic. Very good. Awesome. We move everything to one side. X squared minus 15x plus 36 equals 0. We are moving 3x to the other side. It was positive on one side. It became negative on the other. Again, I look at this and I say, okay, it's a trinomial. Descending order, yes, greatest common factor, so on and so forth. So I'm thinking of factoring. Can I complete the square? Of course I can. Will I do it? Never, unless I'm forced to. Can I take the square root? No, it's not ready for that. So the question is, can I factor? If you say yes, let's factor it quickly. If you say no, we'll use the quadratic formula. X minus 3, x minus 12, and we get two options. And the options are? Very good. Of course, this comes with a huge question mark. I have no clue whether they work or not. So I go back to the original problem. The square root of 3x plus 10 equals x plus 4. And I will plug in first 3. Let's see if that works. So how much is 3 times 3? The square root of 9. 3 plus 10. Okay. And the right-hand side? Okay. Is 13 this? No. So I'm going to say absolutely not. Just the byproduct. Nobody cares about. Okay. I'm going to replace x by 12 now. And see what happens. 3 times 12, 36. The square root of 36. 6. 6 plus 10. Very good. 12 plus 4. Acceptable? Yes. So anything can happen. So please expect anything. One solution, two solutions, or none. So anything can happen. So both may work, one works, or none of the above. How are we feeling about the radical equation so far? Is this okay? Yes? Do you think we can move on? Okay. Of course, please bring your questions on Monday if you have any on these, so we work on more problems. So the next step is equations with rational exponents. And you should say, stop there, because you already told us what a rational exponent means. What does it mean? Yes, what does that mean? If I have a fraction as the power.
Yes.
What did we say? What did we say? Every time we have a fraction as the power, what do we really have? Some radical. However, this is considered a different type of equation because sometimes we will have to do two different steps sequentially, apply sequentially to different steps. So your book presents them completely separate, but they are really radical equations, to be honest with you. But we are going to call them equations like they do, with rational exponents. You can also call them radical equations that are slightly more difficult. That's what it really is. Every time I talk about a fraction as the exponent, I know it's a radical. Okay, so let's take a look. Let's start with, let's say, 34 on page 185. And this is x plus 5, everything to 3/2 equals 8. I'm looking at the time so I can split the video in the middle. Okay. There is a formula in your book that I never teach. If you feel comfortable and somebody in the math lab shows you the formula and you're happy with it, I'm happy with it. This is the formula. There is no need to memorize any of this if you follow my lead and what I'm going to do. But you can say, nope, and I will be glad to accept this. But I don't want to memorize anything. This is just memorization in a way. So here's what I recommend. what I recommend with these problems, you understand that this is different than the previous ones, right? Because here we had this power was 1 and this index was 2. We didn't have a power here. We didn't have another number. We had 1/2. This was 1/2, right? So this is different because there is another number here, not just the denominator.
Oh no.
Right? So this would be something like the square root of x plus 5 to the third. That's what it means. Yeah, but here we did not have anything else but power 1. So my recommendation is, and I'm going to put it in writing, is this. First, eliminate the denominator of that power, and then eliminate the numerator of that power. So number 1, first, eliminate the denominator. The denominator. And then you don't have to memorize the formula in the book. First, eliminate the denominator, which in our case is 2. That's the denominator. And number 2, eliminate the numerator. In our case, this is 3. And then if you always start with the denominator, eliminate the denominator first and then the numerator, you don't have to memorize any formulas for this type of equation. Okay, how will I eliminate the denominator? Exactly how we did it before. How did we eliminate this denominator? We squared, yes. And then the process is, you're right. But we have to say that we squared both sides. Then the left-hand side becomes x plus 5 to which power? Yes, that's it, right? 3 over 2 times 2 over 1 will be power 3. And the right-hand side is 64.
Hold on. Let me see.
So when we raise an exponent to a power, we copy the base and multiply the exponents. 3 over 2 times 2 over 1 is 3. 3 over 2 times 2 over 1. Just write it down. Write down the product. 3 over 2.
I wrote it. I just see.
No, I'm just saying if you write this down on the side, then you will not forget where the 3 came from. Just a suggestion. And then 8 squared is 64. Is this okay now, everyone? Yes? Okay, perfect. So now I'm in this stage in which I have to do what? Exactly, the cube root. Yes, now the reversed operation is cube root. However, you should stop me and say, wait a minute. This is a polynomial equation, and degree is right. The degree is 3. So don't you have to write 3 solutions? So, however, 2 of those are imaginary solutions. But yes, I should be consistent with all the other problems from before. And I should say, yeah, I should get 3 solutions. However, 2 of them will not be real solutions. So the left-hand side, x plus 5. The right-hand side, remember let me refresh your memory on this. When we take the cube root from 8, the answer is 2. The cube root from -8 is -2. So in other words, the point I'm making is every time we take the odd root from a problem, the answer, like in an equation like this, will always be 1. You cannot write plus or minus. For the odd roots, we cannot write plus or minus. Just one sign, which is in this case positive. If we had -64, I would have written -4. But since I have 64, I have to write +4, and the answer is -1, -5 plus 4. And this is the only answer. Now you could say you're contradicting yourself because you said polynomial degree 3, 3 solutions. How come that you're not writing 3 and just 1? It's because in order to find the other 3 solutions, I will have to expand x plus 5 to the third, subtract 64, get 4 terms. This will be 4 terms. because I will have to incorporate negative 64. And solving this equation is not really possible unless we use a graphing calculator that gives us solutions. We will not be able to factor or solve. I can solve it with the TI-86 or with the software in the computer, but we can do it by hand. It's not possible. So for this, in this particular example, we know there are 3 solutions, but 2 of them are imaginary, having the I, right? So 2 solutions are not real. That's why we don't look for them. But yes, to be consistent, degree 3, I should have presented to you 3 solutions.